how's it going? So I figured it's about time I make a few more semi-technical videos about wheelchairs and how they work and things like that. We're going to start at the beginning. How do wheelchair control systems work? And/or why are they so expensive and complicated? We're going to start at the beginning though. I've got a Quickie Pulse 6 sitting over here, and we're going to start by covering RNet, which is a PG Drive Systems control network, basically, that wheelchairs operate on. We're not going to get too technical in this video. I'm just going to kind of show an overview of what the different modules do and how they all operate together to make your chair move around when you push on the joystick and make your seating and all that stuff move. RNet controlled systems are a little bit like Android cell phones in the sense that they have a base operating system and then different manufacturers kind of customize them to their needs or whatnot. Say what you will about the Quickie Pulse 6, it's objectively pretty crummy. It's like they were designing it and they rushed the last little bit. This thing's sort of like an old pickup truck, like a Chevy small block 350 that you've got headers on. Bolts literally fall off of it. You have to be out there every weekend tightening bolts or they're just gonna bounce down the road and things will fall off the chair. But this thing has the most basic form, or the purest form of RNet, as it were. There's no extra weird modules, there's no overlays. The chair's only running one network on it. Unlike Permobil that has two different networks, one of them is highly proprietary. But let's take a brief overview of what modules are on the chairs and how they work together. Then we're going to take some of the covers off this thing. I'll show you some of the different modules and explain a few differences between different brands and why things have gotten more complicated over the years. I've been playing around with this whiteboard quite a bit, and we're going to see if I can actually make it work for its intended purpose today. Now, all rehab chairs, that's ones for people that are using them full time and have power seating, so you can adjust your legs and the tilt and recline and all that stuff, basically have three main parts that make them all work. We're going to start from the bottom and work our way up. So, at the base of the chair, we're going to have, we'll just draw it as a box. This is going to be what's known as the power module or the motor controller or the main controller. All those names are technically the same, but it's the one that sits down in the base of the chair and the electric motors are plugged directly into it. Also, the batteries are connected directly to that, and that's what sends the power out to the motors to make the chair move and all that. Then we're going to have another module. Well, module, it's the joystick. This is the human interface that takes your hand movements and converts them into something that the chair, in turn, makes into motion. And then lastly, we have the seating control module. Now, different brands have a bunch of different names for these things. Some are intelligent seating control modules, some are seating control modules, some are multi-function modules, and they perform a few different functions based on the chair you're using. But their main goal is to operate the electric actuators that move your seating back and forth. So we've got these three modules here. So we'll call this main motor controller, S for seating, and J for joystick. Now, I'm not going to get too much into the technical aspect of how these modules communicate in this video. That's going to be for one later on. Older wheelchairs operated on what they called a serial communication, which is just point to point. But newer chairs operate on a CAN bus network, which basically is sort of like Ethernet cables where you can plug your modem and your router and all the devices into one spot, and they all automatically assign themselves to the task that they're designed to do. When you plug it into the network will recognize it, know what it is, and it'll automatically integrate with all the other modules. Now, CAN bus is a very robust network that was pretty much invented for automotive use, and it just uses two wires, well, four. Two of them are for power, plus and minus, 24 volts. Everything on power chairs is 24 volts. And then there's two more lines for transmit and receive. That's for data. So we've got our motors here connected. And we'll just do this. And then basically we've just got lines connecting the motors to the controller. Then we'll just connect our motor controller to the seating control module. And then from there, it goes to the joystick. Now, on RNet controlled chairs, all of the software and programming and customizations are housed in the main controller. So when you change your speed settings, you want your chair to turn faster, back up quicker, accelerate more slowly or whatnot. All that is housed in this main module. And then the joystick basically takes the input from your hand movement, sends that over to the motor controller, and again, it doesn't matter what path it takes to get there. They all communicate with each other real time. And it converts that into the signals that the motors need to move the chair. Now your seating controller, typical rehab chair is going to have like 3 power functions, we'll say. So we're going to have one going out to recline, one to tilt, and say one to power legs. Now this Quickie chair over here is a good example because it's actually running 5 actuators to control those 3 functions. And I'll show you on that chair here in a little bit. So it adds a little bit more complexity. So our recline has 2 actuators, our tilt only has 1, and then the power legs have 2. So very quickly, you start getting a lot of wiring and a lot of control things going on here. But this is our basic layout. We've got these 3 modules here. All the rehab chairs use these. So let's take a look at this Quickie Pulse 6 over here, and I'll show you what each one of those looks like. So here we have our Quickie Pulse 6. This one has power legs, it has tilt, and it has recline. And we've got one of the sort of standard RNet color LCD displays on here. And you know, you can go through your different modes for seating and all that stuff. Now in most of these chairs, the main controller or the power module is going to be down low somewhere on the chair, really close to the batteries, because they want to keep the cables as short as possible because there's a lot of amperage and stuff running through there. There's some chairs that have them mounted in other places, like some of the Amy Systems chairs, the controller's mounted on the front, but it's still going to be on the base of the chair. The seating kind of has its own thing. So if we pop this back cover off, I was just going to say this one doesn't require any tools, but these little pins seem to be stuck. Here. There we go. This cover will slide off of here. There's usually a combination of like Velcro and pins or bolts, and then some little tabs or something like this. And there's some slots down here in the frame that, that holds this thing in place. So this here is our main controller. In its most basic form, it's going to have 4 or 5 connections to it. This one here in the middle is the battery cable. That connects everything directly to the batteries and powers the rest of the chair. Then these ones here on the side, these go out to your motors. And the motors are going to have the windings that allow the chair to move, and then also a couple other wires for the parking brakes to turn on and off. That's that clicking sound you hear when you move your chair around when you start or stop. These are going to have 4 connections each in them. 2 are really big and 2 are really small. Then the 4th connection we have is our RNet cable. This is our network interface that connects everything on the chair together. This has the CAN bus data lines in it, and this connects to all the other modules, and basically it sends out power and data, and it also receives data, and this just basically daisy chains to the rest of the modules in the chair. So we'll plug that back in. This thing gets hot. This is a 90 amp controller, and they also have 120 amp controllers, and there's a whole different debate as to how much power they actually use and blah 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 and this and that. But these things will get warm when they're under load because they're handling the movement of the entire chair. And usually a user and a chair, I mean, you're going to be in somewhere in the 400 to 600 pound range when you're running around doing stuff. So as you can see, this RNet cable here connects, and it goes up here. And if we follow this up, it goes into this wiring harness, and then it goes into this back cover here. And this is where the seating control module is. So let's pop this off real quick, and I'll show you what that looks like. Okay, so we got the fasteners out, and this back cover will now come off of here. And you can see here, there's suddenly a lot of wiring. Again, this chair uses 5 actuators to control the 3 different power functions, and I'll explain why that is here in a minute. So our wire comes up here from the main controller through this wiring loom, and then it goes over here to this thing that I call a multiplexer. This is where all the network cables can plug in, and they pass the power and the data communication through to the rest of the modules. This is basically like a power strip, or I guess like a network switch or a router. Would be a more apt analogy for this. But you plug all the modules into this thing, and then from there, it goes out to the joystick, which is over there, and then another one comes out here to the seating control module. Now this
is an RNet seating control module, PG Drives technology. This is a 6-channel controller. So it can handle 6 different actuators, and there's a few different versions of these. Some of them have lighting controllers built into them as well. If we look at the bottom of this, you can see there's 4 extra caps right here, or connectors. Now I've pulled these plugs out and there's nothing there. If this was a controller that had the lighting modules built in, these 4 caps would be removed, or underneath them there would be pins you could connect lighting to. See how it says NA? Now this is a very simple control module in the sense that it doesn't really have any software or programming in it, and there isn't really any feedback as to what the actuators are doing, other than when you tilt the chair or recline or use your power legs, when the actuator gets all the way out to the end, the motor's going to jam up because it can't move any further. So what this thing does is it looks at the amount of power or amperage that actuator is drawing. And when it gets to the end of its stroke, it's suddenly going to have a surge of amperage. And this thing sees that and then shuts off the power to that actuator to keep it from getting damaged. Now, that's not necessarily the best way to do this, and constantly bottoming out and topping out your actuators is going to wear them out a lot faster. But this was the most inexpensive, simple system that they could accomplish it with. So this thing doesn't really have a whole lot going on in it. It doesn't have any feedback. The only feedback this chair has for seating position is this little guy over here. This is like essentially a Mercury switch or a tip switch, and this is set at a specific angle. So when the entire chair tilts back far enough, whether it's a combination of reclining or tilting and reclining, this thing will send out a signal to the main power controller and tell it, hey, we're in a really strange, unstable position. We should move at half speed. And a lot of times these things will have 2 settings, or maybe there will be 2 of them. There's one to slow the chair down, and then when it tips far enough, it'll completely stop the chair from moving. And then you have to sit back up in a normal position before the thing will let you move. So we've got a whole bunch of wires coming out here, and there's one going to the recline actuator, which is this big long one right here. This is just sort of a gas stabilizing strut that's mostly for ride quality. It's pretty much unrelated to the control systems. This is just like one of those things that holds open the back hatch on your car or something like that. And then there's a second actuator over here, and again, I'll explain in a minute what that's for. Then we have another wire coming down here. This is the tilt actuator. You can't really see it, it's buried down under here, but these are basically just power wires. Some of the actuators use that current sensing to tell them when they're at the end of their stroke and when they're going to stop, and other ones have little micro switches. Now this has actually 4 wires on it. So 2 of them are to power the motor, positive, negative, and then that gets reversed by the controller to make the actuator go the other way. And then the other 2 are for a micro switch that's down here. And then as this thing tilts, it gets to a certain point and there's a little metal plate that hits a button, and that tells the controller, hey, stop, we're not going to move anymore. And then there's another set of wires that goes around front to the leg rest as well. Now we've all seen the way the seating controls work on these things. You hit your mode button. This one doesn't have the auxiliary buttons next to the joystick, so you have to hit mode and then scroll through all your seating settings. But we've seen how these things work. You've got your recline, you've got your tilt, and you've got your power legs. These are all pretty simple, basic functions. Now, let's get to that part where there's 5 actuators controlling these 3 functions. This chair is a perfect example of how things started getting more complicated and then control systems had to adapt over time. So there's a thing called shear reduction. When you're reclining the chair, if the backrest doesn't move up or down while you're doing that, you can wind up getting pinched down here between the seat cushion and the bottom of the seat back. And that's particularly relevant on a chair like this that has sort of a wraparound backrest. If you just recline the chair, you're going to end up getting a bigger gap right here if this doesn't move. So what they had to figure out was a way to get the seat back to slide up and or down as it's tilting. And the easiest way they figured to do that without adding a bunch of extra sensors and electronics is to run those 2 actuators back there. So in its stock form, as you recline the chair, the seat back is going to go down and get closer to the seat cushion as it tilts back. Because as that's tilting back, this gap would naturally get bigger, and then it does just the opposite as it goes up. Now, I wound up changing the programming on this one a little bit. Let me see if it's still going to work the way it normally does. Okay, so this one I changed the programming so that it only operates 1 actuator at a time. because I wanted to be able to adjust things when I was using this daily. But see how there's a different gap down here now? It'd be real easy to get pinched down here if that thing wasn't sliding up and down as it was reclining. And the way this is programmed, I can actually show you. That second actuator I've got on a different profile. So as I adjust this, see how that moves? The whole seat back goes up and down. And it changes the size of that gap.
Now for me, this was a particularly useful function at the time because I wanted to be able to adjust the height of my seat back. And the problem with just having two actuators with no feedback sensors or whatever, it just relies on, well, hopes and dreams for them to stay in sync. And what would happen a lot on this chair, if you reclined a lot, those actuators would get out of sync because it's just assuming they're always going to both activate at the same time, spin at the same speed, and stay in sync. So after reclining a few times, my backrest would be way higher than it should be, and I couldn't get it back to normal. So that's why I used a programmer and changed the way this thing works a little bit.
So this was a solution to the problem of shear reduction. Now a lot of chairs like this Quantum Forefront that I'm sitting in and all the Permobiles out there, they have a mechanical solution. There's an arm in the back of this thing that rides in a track, and the whole seat back is just basically on rails. So as the chair tilts back, it pushes on the arm and it cantilevers this lever that's slotted into the back of the seat. So it slides up and down perfectly every time and stays in sync as you're tilting and reclining and keeps that gap from getting huge like that. Now the exact same concept comes into play here when it comes to the foot plates. Just because of physics, as these raise up, they need to also get longer because the pivot point's down here and you're sitting all the way up here. So if they didn't extend, your legs or your knees would be up in your chin by the time these raised up. So similar concept here. They use two actuators. There's one to adjust this angle and then there's one to adjust the height. And again, since they get out of sync all the time, I just separated those into separate channels. And as you can see here, now the foot plates are going to get longer. And then there's a separate actuator to control the angle of them so they can go up and down. So typically, in its stock form, both these actuators would activate at once. And again, who knows if they're going to stay in sync. And once they get out of sync, good luck getting them put back. I don't even know how you would do that, honestly. Now me, being a power user, as it were, I actually prefer this chair not having the actuators operating together because it gives me a lot more fine-tuned control for pressure relief and repositioning and whatnot. Like sometimes when I'm sitting in this Forefront, I wish the foot plates were a little bit higher. Other times I wish they were a little bit longer. So with this basic setup, it's pretty easy to accomplish that. Same with the seat back height and all that. Great for changing pressure relief, repositioning, all that good stuff. So going back to our diagram here, we can see based on some different needs with the shear reduction and the leg rest needing to extend. Oh, by the way, Permobile, well, up until a couple of years ago, they've used a mechanical solution similar to the seat back height adjustment for the leg rest. If you've ever looked inside your leg rest on a Permobile, you might see this thin fabric strap. And there's sort of a mechanical arm that's spring-loaded in there. And as you elevate your leg rest, that spring expands, lets the strap out further, and then it mechanically makes your footrest longer. That's one of the things I like about Permobile and some of the other manufacturers. Really good engineering yields a very simple result. I mean, you can spend a lot of time designing something and make it overly complex, or you can figure out a way to do it where it's just simple. Now, Permobile has gotten away from that. They're still very good, they're still very, very well engineered, but they're butting heads with the limits of the RNet control system. So here's our basic diagram of this chair over here at the Pulse 6. Now the RNet seating control module, again, I keep saying it has no feedback whatsoever. So let's say we wanted to take this chair and give it all the feedback sensors. We'd still have our motor connected to our joystick connected to our seating controller, but we've got three different functions we want to control now and monitor. So same setup, but we're going to have these three boxes here are representing the functions, not necessarily the actuators. We've got power legs, we've got recline, and we've got tilt. So we're going to have the similar connections. We're going to have control lines going to each one here, and these are what is going to power them, make them go forward and back and all that. But now we're going to need more sensors. And
the best way to do this is to have two sets of micro switches on each controller. One for fully extended and one for fully retracted. So now we're going to have two more sets of control lines going to each module. And each of these control lines are potentially going to have another two wires. So now we've got all this. And then let's say we want to have these little buttons here so we can control our seating without going through the joystick. That's going to add yet another module over here. That's only going to have one connection going to it, so not too big a deal. But now suddenly we've gotten super complicated. We've got 6 micro switches, bunch of control lines, bunch of actuators, and then we still haven't addressed the leg rest extension and the shear reduction for reclining. So on this chair, if they wanted feedback, we're going to end up having even more modules. So for recline, we're going to have another actuator over here, another one on the legs, then we're going to have to run control lines to that, control lines to this one, and then since it's the same problem with the actuators, we're going to need the feedback lines for the micro switches. This is a mess. We've got way more components now. A lot of things are going to break. We've got what, like 2, 4, 6, 8, 10 micro switches, piles of wiring, and honestly, the RNet control system is not designed for this kind of complexity with its stock seat controller. So Permobil did something kind of interesting. They took this entire mess with the seating controller, with all these wires and all this chaos and everything, and they threw it right in the trash. They designed their own module called the ICS, which literally is spoofing an RNet seating module. It makes the main controller think that it's connected to an RNet seating module, but the ICS is running its own completely separate isolated network. Now, that sounds really complicated. On paper, it simplifies things a little bit, but now we have 2 different control networks operating on the chair. And again, we're going to run into issues because RNet's not designed to control all these different functions and sensors. And that's one of the reasons now the 5 Series chairs, like the F5 and the M5, are starting to have weird glitches and problems. They've got so many things attached to these networks, and they're just pushing the limits of what it can do. While most of them are reliable and fine, you're going to get a number of them, and I've chatted with a number of people that are having really strange, unexplainable issues on their 5 Series Permobils. But it comes down to the network and the way it operates. They're trying to do way too much with it. So Permobil is like, okay, we're gonna have this little magical box here called the ICS. It's gonna make the RNet chair think that it's a seating controller, but it's gonna run its own software, it's gonna have its own network, and in a way, it simplified everything. So instead of just running the 2-pin cables to each actuator, Permobil has 3-pin cables that run to each actuator. So let's draw some actuators here. We've got our legs, we've got our tilt, and we've got our recline. Now all they have is 3 connections. 1 to each of these actuators. These actuators now have their own logic boards in them, they have their own processors, and they even have Hall effect sensors. I know I said I wasn't going to get too technical on this, but let's just say Permobil came up with their own solution, which worked really good at the time. It simplified things while simultaneously making it complicated. We're going to cover the ICS and the RNet integration stuff in a different video, but for now, I'm just trying to illustrate with all this that things kind of had to get more advanced because we need more functions on the chairs, we need them to do more things, we need them to sense their positions. Now there's a number of people out there that are old school in the sense that they're going to say, we don't need all this. I just want it to do what I want it to do when I push the button, and I'll be the control of what happens. I'll be the judge of if it's tilted too far. And you know, that makes sense. I'm kind of that mindset as well. But we have to think about the people that are using rehab chairs. There may be limited function, there may be alternative controls, you know, head arrays, chin controls, sip and puff systems, and those all have to be able to integrate. So while it would be nice to keep things simple, we can't really do that. I mean, again, if we go back to the old vehicle analogy, yeah, everything used to be carbureted and it worked good, but things have changed. We're concerned about efficiency now, we're concerned about emissions, so things have to adapt and things have to progress over time. And while it would be nice to keep things simple, things have to advance. So in our vehicle example, now we have fuel injection. Because we have fuel injection, we have to have computers. And because we have all that, we have to have more sensors, and we have to have more things to control those. Yeah, it would be nice to keep things simple, but we're learning as time goes on that things need to change, people's needs change, and really it's one of those deals. I was always a diehard fan of not using fuel injection. I don't want these dang computers. But then I realized later on, this is actually good. So there's always going to be an adaptation period as technology, progresses, but that's the thing. More examples. I love metaphors. Think of real estate agents and the internet. When online real estate became a thing, there was a huge battle with realtors or realtors or however you're supposed to pronounce it, and people selling stuff online. But the internet won, and they had to adapt or they had to find new jobs. It's just one of those things. It's the way it works. Well, a chair like this one works great for me. I've got a couple friends, for example, that don't have the function levels to reach up and hit the power button on their chair. So how are they going to control this mess? If we're using head switches, head arrays, sip and puff stuff, chin controls, all that, there has to be more integrations. And there has to be a way to effectively control all this stuff. And not to mention the people that just want a chair that works. They want to get in, they want to move the joystick, they want it to move, they want to hit the recline button, they just want it to work. They don't have to think about adjusting the height of the backrest as it reclines or making the leg rest get longer as it goes out. And, to be honest, it makes sense. That's the thing with this technology, and most technology in general, is it has to be catered to the average user. Now, there's a number of people like me out there that are frustrated by this, but at the same time, you got to stop and think. It has to be this way so that the majority of people can operate things and they'll work reliably. Now, on this chair, yeah, I can tilt it back, I can change the heights, I can spin in circles at full speed while I'm laying completely flat. Now, might I hit my head on the wall doing that? Maybe. Enter the lawyers. So since this is medical equipment, there's a lot of licensing and laws and rules and things like that. And there's always the possibility of getting sued. That's just how things are in America or the rest of the world. I don't know, wherever. Lawyers are just a thing. And we have to dance when they tell us to dance, unfortunately. So, while it would be nice to be safe all the time, they have to bake in all this safety stuff, like say, hey, the chair's gonna go slow when you're tilted way back, because your center of gravity is now different, and if you hit a ramp at speed or try to turn corners, your chair might tip over. So that makes sense. But then there's the whole thing about the chairs being locked down and not programmable. And that's a tricky one. Also has to do with the lawyers. These chairs are basically computers controlled by software. It's just a bunch of hardware you're sitting in, and all the software controls everything. So, if you can get access to that software, you can change all your settings, do whatever you want. But when that happens, manufacturers are afraid that a user might change something that is going to get them injured, thus getting them sued. So, it is unfortunate, but also there's some technical issues as well. Like I was mentioning with the ICS on Permobil, replacing the seat control module, the RNet and the ICS, while they do sort of function together, you can't control either one of them from the other side. They don't exactly fully integrate with each other. While the main power module may think that it's connected to a seating controller, secretly it's connected to this ICS box, it'll still function and do the basic things, but when it comes to programming and changing settings, the two systems do not mesh. I actually had to take notes to make this video. There's so many different things, and trying to stay on course is really difficult. But, yeah, the wheelchairs are locked down roughly. And there's a barrier to entry, whether it's cost of buying a programmer and or the knowledge of knowing how to use them or make adjustments safely, or also the DME providers like the wheelchair shops and whatnot that work with insurance companies and all that, whether they're willing to do anything, or mainly, if they even know how to do stuff. There's no publicly available theory of operation manuals for PG Drive systems or Curtis controls or Lynx or Invacare or pretty much any of these things out there. It's pretty much trial and error. And there's a lot of things and settings you can change that will physically damage stuff on the chair. I mean, I could get out the programmer and change some settings on that thing, go out to my mailbox and back, and have fried both of my motors. So there could be a middle ground, and they could say, okay, well, we're going to allow these changes to be made, but not others. but that would require them to spend a little bit more time and develop a little bit more stuff. It would cost them more money, but mainly it wouldn't make them any more money. And they're like, settings are good enough, we're gonna leave it there and you can just deal with it. Now that's what I don't agree with. I can see the other side of it, however, when it comes to people constantly suing them. I've had people try to sue me over things that were taken out of context or things that I didn't actually say. Yes, I might have given you the idea that you can change this setting, and then you were like, oh, maybe I can change something else, so I'll go do that. Oh, something broke. I'm gonna come after the guy that put the thought in my head. So while it does suck, I kind of see where they're coming from. It is a bit of an unfortunate reality with medical equipment specifically because it's so highly regulated, and if anything happens, everyone's gonna look to blame someone. And don't get me wrong, if there was a poor design and it resulted in someone getting hurt or injured, I'm all for suing. Sue the pants off of them. I mean, that's what happened with Immicare when they shut down production a while back, or actually the FDA shut them down. They had some serious safety issues. But anyways, that's just sort of a basic overview of the wheelchair control systems, why they're getting more complicated, why it's harder to do things. And here's the thing too, all the manufacturers are using their own versions of things. They're not all working with each other. So every control system is different. You can't just say, okay, well, here's how you do it. If I want to change the turning acceleration speed on this chair, I know how to do that. I get out the laptop, I do it. If I want to do it on this Quantum that I'm sitting in, or even an older Quantum, I've got programmers for them, but the way you go about it is very different. And you can't just say, okay, here's a program, you can use this. Even the same model and brand of chair, even the same production date, things are slightly different. So it makes it really difficult to say, okay, this tune is going to work for this person's chair. This other person has an identical chair, let's just drop it right on there. It may respond completely differently. And that leads us down another path when it comes to having parts manufactured and standards of quality and all this other stuff. I'm trying to just stick to scratching the surface here. I'm going to make future videos about some of these other things I've been talking about, but for now, there's 3 main things on your chair: the joystick, the seating controller, and the main controller, or the power module. And that's how they work. This got confusing in a hurry. I started talking and then I wasn't even sure how to say what I was thinking. But anyways, I'm coming up with a list of different topics and videos, and we're also going to jump into the really technical stuff at some point when it comes to programming and some guidelines for programming your chair. Again, I can't say do this, this, and this will work, because all chairs are different, all users are different, people weigh different amounts, their seat position may be different, and there's just so many factors when it comes to these things. But to everyone that always says, why do you have so many wheelchairs? This is exactly why. By the way, I have 2 of these Quickie Pulse 6s. The other one has a completely different control system that's not RNet, and it was garbage, so I mounted a generator on the top of it. I have an 8 kilowatt gasoline powered power chair generator. I deemed that was what it was good for. People outside were staring at me. I'm still embarrassed to hold a camera in front of my face. Yeah, you can't see me now, I turned the light off. So as we go hurtling forward into the future, I really hope manufacturers will listen to the users more. I feel like there's a growing number of people that are becoming much more proficient with chairs. I'm not saying they don't have, like, you know, skills or whatever, but there's a growing number of people that are expecting more from their equipment, and they need it to do very specific things for their need. And this whole mass programming of all the chairs to fit everyone from the factory needs to change. Again, unfortunate reality with some of the stuff and giving you full access to everything, but I understand both sides of it. At the same time though, we really need to do something about this. I mean, I'm not like a letter campaign writing, phone call, voicemail leaving type thing, but I don't know, maybe that's how you get stuff done. But anyways, I'm not exactly sure what I'm saying with all this. Hopefully this was helpful and gives you a basic understanding of how wheelchairs work and why they're so complicated and getting more so. Permobil is announcing something new here, I guess in a few weeks, and to be honest, I kind of hope it's a new control system. At the same time, I also hope it's not. See the dilemma we're in? I want something new because the old one's maxed out, but if we get something new, am I going to be able to change anything on it? I've spent a number of years learning all this stuff, And for example, again, this forefront I'm sitting in, I can't program anything on it. There's no way for me to change anything unless I buy this $600 thing, and then I can't access all the settings on it. So you can see the dilemma. It's good and bad, and it's simple and very complicated. I hope that makes sense. By the way, I'm sure regular viewers are aware this channel doesn't really have a theme, and I'm not changing anything. I'm not gonna stop doing vlogs or other projects we've been working on. I've just, I've been doing some work. I do random contract stuff for people's stuff and things, whatever, but I've been literally staring at computer screens for the last 2 months. And that's why the videos have been a little bit further between them recently, is working from 10 p.m. to 4 a.m. It really screws up the sleep schedule. Insert excuses here, but this is just something I've been wanting to do for a while. I've got a whole notebook full of things, and I figure the information in here, if it stays in here, doesn't do anyone any good. So we're gonna be doing more of these, like, what am I gonna call it? I think shop class is what I decided on. Yeah, I think shop class, that's what we'll call this series. So you're gonna see a few more of these videos over time. And today I just figured it's been 6 days since I uploaded something and I haven't gone anywhere and done anything. Like, I've made coffee, but you've seen me do that dozens of times. So I just figured I'd pick up the camera, knock one out, and once I make a video, that's the motivation. I have to finish it. I can't leave something unfinished for too long. I mean, we can stretch that time out, but I don't know, whatever. I'll see you guys in a few days.